Today we're going to discuss phase changes. I'm sure we've all seen how water evaporates or ice melts, and some of us have likely wondered why ice floats. Today we'll be looking at these behaviors and the equations that govern that kind of behavior. The first thing I want to do is introduce you to a chart that you may have already seen, the phase diagram. Does this look at all familiar?
So, actually, problem number 17 from yesterday's work, problem number 7 from yesterday's work is this diagram. So,
Okay, so the y-axis is pressure, the x-axis is temperature. It's always important to label your axes. Okay. Can anyone here tell me what temperature water boils?
130.
Sorry, what? 130?
Something 130.
Okay, any other ideas? 130, so I'll put that up. That's my idea. Anyone else have an option? Huh?
180.
180 what?
Fahrenheit
Degrees Celsius, Fahrenheit, Kelvin?
Whichever's the correct. Yeah, whichever's here.
Okay, alright. So if you had said Celsius, 100 degrees Celsius, that would have been right. In Fahrenheit, there's a way to convert these values. I think it's around 180. So how many of you have considered what the water molecule looks like?
What?
What does water at the atomic level look like? Any idea? It's a unique molecule, so it would kind of look like Mickey Mouse,
Oh, yeah.
where you have these hydrogens kind of like ears, and your oxygen, and they're at an angle. See, they're not linear. It's not oxygen, hydrogen. It's more like an angle here. We call the structure bent. So these hydrogens will find another oxygen and form what we call a hydrogen bond, where they'll be attracted to the oxygen. And then it'll keep happening over and over. And so when ice freezes, it creates this crystalline structure where they're sort of fixed in place. And it's a constantly repeating pattern. Consider now if these bonds weren't as fixed in place and the water, being a liquid, was sort of moving around. Molecules were just kind of bumping around, moving through past one another. The bonds, it does form bonds, but they're quickly fixed and then released as the water molecules move. So the structure doesn't form, and as a result, you can pack the water molecules closer together. For that reason, around 4 degrees Celsius, water begins to expand as a result of this crystalline structure. There's a little bit more to this structure because oxygen on the opposite side has what we call lone pairs, extra electrons, and these electrons are what make the hydrogen bonds possible. However, it's not a flat molecule, as you know. The hydrogen, the extra electrons kind of poke out of the board and into the board at angles. So as a result, this is three-dimensional and not a single sheet of ice. What about this graph? I'm going to put up another graph for you. And this might be a little bit more familiar. So have you guys seen this graph before? I haven't labeled it yet. I'm just trying to gauge your understanding. No idea?
It looks like stairs.
Right, they look like stairs. But take note of the x-axis and the y-axis, temperature and energy added. So as you add energy, energy is typically measured in joules or calories, the temperature will rise. Let me put the definition for you. Okay, so temperature is the average kinetic energy of the particles in the system. And heat is the flow of thermal energy. I'll put that,
Energy target.
okay, so each of these lines represents a different stage. If I were to label the temperature here, and we're still discussing water, I would label this 0 degrees. And up here, it would be 100 degrees. So now tell me, what happens at this line? If this is water, and it's at 0 degrees, what's happening at that line?
It's being heated up.
It's freezing.
It's freezing, yes. Okay, excellent. Freezing. So, therefore, at line A, water is a solid. So let me write that here. So at point A, or rather line A, water is a solid. What about here? We'll call this, I'll leave B there for now. Let's talk about line C. What's happening at line C then? What's the, sorry? Yes, the temperature has risen. And that's because you've added energy into the system. And so these molecules are now breaking free of their frozen bonds, and they're moving around. They're still forming bonds, but they're breaking them and they're moving around. So what do we call that state? Liquid. I heard liquid. So, okay, and then finally, what is the state up here? Yes, right. Okay. So, I'm sure some of you have noticed something interesting. And that interesting thing is, why aren't the lines like this? You see this diagonal line? Why isn't this diagonal line just going up this way? And why isn't this diagonal line all the way over here continuing up this way? Why isn't it just a straight line? Because energy is being added. Between these states, between the state of solid and liquid, you need a sum of energy in order to break some of these bonds, in order to go into the next state. So there is a pausing, if you will, of the temperature while enough energy is collected in order to overcome the energy requirement. And the same thing is true for the liquid to gas state. As you know, water forms two of these bonds, these hydrogen bonds, and that's one of the reasons why water makes a good absorber of heat. So I mean, compare that to gasoline. So as a result, you have these gaps here. Now, what I'm going to do is I'm going to associate each of these lines with an equation that will allow you to calculate the amount of energy during these changes. So, Okay. Have you guys ever seen any of these equations? I'm not expecting you to. But just okay. So you haven't seen them. Okay. So let me explain these step by step.
It reminds me in math when we do the n triangle ABC like that.
Yeah. So these are mathematical equations. You're gonna more specifically, each of these letters are a variable. If you've taken algebra, you know what I'm talking about.
Yeah.
So you'll be plugging in numbers into these variables. So I'll tell you what they are. A Q here is the amount of heat lost or gained in joules. So when we're talking about adding heat, you should be thinking of Q, the amount of heat lost or gained in joules. M, anyone want to guess what M is? Yeah, that is true in math, not true here. So I know what you're talking about, but here M is just a mass. So you'll put this in grams. So if we're talking about grams of water that you want to heat, you plug in the grams there. C is what we call the specific heat. You guys heard the specific heat yet? No? Yes? You have? Yeah, so what is specific heat? Oh, you have vocabulary, excellent. Please read it out.
The quantity of heat required to increase a unit mass.
The amount of heat required to raise a unit mass by what? Does anyone else have that definition? You all seem to have the notes with you. Please fill in the notes for your classmate. What definition do you have?
Quantity of heat required to raise unit mass of material.
Okay. Well, we're just going to stick with A for now. So find the variables associated with that question, plug them in. Let me know what answers you guys did. Let's look at question.
Hey, I didn't say
Anyway, I'll link that exchange. Okay, so how many of you have noticed the problem with the question I asked?
I don't know how to do it.
You're lacking C, the specific heat.
We need an example.
So this is your example problem. You're actually going to do it for me. You have numbers, you get all multiplied. How many of you in here have calculators? Good. Take them out. So I want you to pair up in groups of threes. Each of you will do one equation. Okay, so you might have to move. Some of you might have to move. I know some of you already in a row of three. Those of you who are not in a group of three, please find someone else either behind you, and then. Okay, so let me clarify the question. Okay, remember, you're going from 90 degrees So find someone else, or you're gonna have to read the last problem yourself. Okay. You guys are
Maybe I need a mess.
okay.
You go over here, because we're gonna have to.
Many.
Okay, look.
Many.
Are you wanna stay in the group? Okay. Okay, so class, wait, listen. One of you three will be using equation C. The second person will be doing equation B, and the third person will be doing equation E. It's similar to what I have here. It's similar, except for the delta H with vaporization. Here you did fusion. This will be vaporization. So the vaporization value I circle. Go ahead, get started. Or choose equation. You want to C, D, or E. Okay, how are you? Using the values, problem. Okay? Which equation you don't see? Okay. Write down the equation, and then plug in the values.
I see it, it's on the.
Which equation you guys? You don't see. Okay. How are and then add up your numbers.
I don't know, right?
Change maybe grams water and 90 degrees to steam. Okay? Okay, next up. Which equation have you left? There's three questions, C, D, or E. Which one are you guys doing?
I'll do.
No,
What do you want,
C,
Papa?
D, or E. Okay, C.
What?
Okay, class, I'm waiting to see which group is the winner. That's the idea.
Oh, there's a prize. What if it's like you print out?
Yes, sir.
Yeah.